in this piece, we want to use the mean value theorem to find equations for lines tangent to the curve that have slopes equal to the average rate of change of the function over the given interval. We're going to confirm our answers by graphing the function and the tangent lines, provide a rough sketch of the graph. So the idea is to satisfy the conclusion of the mean value theorem is often how it's expressed in the AP exam. So what I want to do for you is write down the conclusion of the mean value theorem. And this you do have to know for the test, which is f prime of c is equal to, and who remembers what comes after that?
F of A.
Good, f of b.
Oh, that's, I meant to say B.
Minus f of a divided by
B minus A.
b minus a. Sorry about the little squiggly sign I've got there.
It's weird.
Okay.
Oh, it's supposed to be another bracket.
Yeah, but notice our function is negative x squared minus 6x, okay? Now, I don't know exactly what this function looks like over the interval -4 to 1, okay? But let's say that looks something like this, okay? Let's say it looks something like that, okay? Then what we're trying to do in this situation is we are trying to find the value c at which the line tangent would have the same slope as that secant line. Okay, Jojo, you ready?
Yep.
You tell me when I get to the spot on the graph where you feel like the slope of the tangent line would be the same as the slope of that secant line.
Okay. Wait, whoa.
Yeah, I know, it's kind of fun. I was looking forward to that all day. All right, ready? We'll try again.
Okay. Okay, like there somewhere.
Like there?
Yeah. Good job, Jordan.
Yeah,
It's close enough.
Yeah, it's close enough. I'll kind of redraw it a little bit here because I probably didn't do a very good job of drawing it. She probably picked a real good spot, and I didn't do a good job of drawing it.
Yep, that's right.
Okay, something like that. See how the tangent line is the same slope as that secant line? So we want to find this value c. Now what I used to do was I used to make the students graph this section, and then I also used to make them then find the equation for line tangent, graph it on their calculators, and then they get a visual representation of those were the same. I found that that's a little bit more extensive than what we really need to do. I just want you to know you could check your answer that way. So all we're going to do is we are just going to find c. That's what you'll be asked to do on the test. Find c. Okay? We won't have to find the equation for line tangent. So if we want to find c, we need to work with both sides. I probably don't do a good job, for whatever reason, of explaining this because people fall apart on this part of the test. They either don't do the right side or they don't do the left side. And I don't understand why. So as I'm explaining this, if you see something, let me know. But I don't get it. So we're going to do the right side first, and then we'll do the left side. Okay? This is my A value. This is my B value. So I'm first going to compute f of b. I'm going to need that. What is f of b? I've got a -1 minus 6. -7. Good. And I need to compute f of a. And f of a, I plug in -4. So I have -4 squared is 16. Make it -16. So it's going to be -16 plus 24 or minus 24?
Minus 24.
Plus 24. Plug in the -4. So -16 plus 24 is 8. So I have those two values. And so what I need to do is do f of b minus f of a over b minus a. So 8 minus -7 over what? 1 minus -4. Good.
Isn't it -7 minus 8? We did that.
Oh, yeah. Yeah. You always got to be right. Okay. Try again. I'm just joking. Just been making a lot of mistakes lately. I'm self-conscious.
You're taking risks, that's why.
Taking risks. Let's go. I'm not afraid to be wrong.
Wait,
I took a risk yesterday.
What'd you do?
I
She-
went to the gas station.
So it's
across
f
the
of
way.
b minus f of
Like
a.
20 miles left on.
Yeah.
I had
I
written
made it.
f of a minus f of b.
I said 20 miles.
Oh, what's the bottom part in?
The bottom is
Oh, yeah,
b
you guys
minus
said 20
a.
miles.
So 1 minus -4.
Never mind.
Okay. All right. So what do you get in the top?
Never mind. I know what you're saying.
We get -15. Good. Divided by what's the bottom?
5.
5 for an answer of -3. So we take that -3, that is the right side, so I'll put it on the right. Maybe that's part of my problem. I'll put -3 on the right. What goes on the left?
Why is there a different side?
That I just did the right side. We just computed this.
Oh, do we
Okay.
flip them around and do?
Equals, now what do I need on the left side? The derivative. What's the derivative? -2x minus 6. So everybody see that that's the left and that's the right? Okay. So I get -2x is equal to 3. Divide by -2, x is -3/2. I'm going to check to make sure that that sits in our interval. Does the value of -3/2 sit between -4 and 1?
Yes.
It does, okay? So, again, remember the mean value theorem said there will be a value c that sits within that interval such that that is the case. Assuming that the function is continuous and is differentiable throughout the interval. Okay, number 3, true or false? Number 3 is differentiable and continuous for all values. False. Where is it not continuous? Is -3 in the interval? No. So we are okay with this function. Even though it's discontinuous at one spot, that spot is not in the interval. So we can go ahead and apply it. Let's start by finding f of 4 and f of -2. What is f of 4? 2/7. F of -2. 2. So again, I'm working on the right-hand side. I have 2/7 minus 2 all over what? 4 plus 2. Okay. Show you guys a little trick on your calculator. You ready? If you would like to use your calculator in this situation, in the top, I have parentheses, 2 divided by 7. Minus 2, parentheses, divided by 6 in the denominator. Okay. I press enter, and you might get a number that you really don't like. Does anybody remember how I can convert that to a fraction? Math, enter on convert to fraction, and we'll take that and turn it into your -2/7. Obviously, we could have done the work. If you're looking to, save time, there you go, -2/7. So that's the thing that will sit on the right-hand side. What goes on the left-hand side? I have to take the derivative. How would you take the derivative of that? So everybody goes that route. I get it. I think it's easier to use the chain rule in this situation. Is it not? Isn't this 2 times x plus 3 raised to the -1 power? We dice this up real quick. I've got 2u to the -1. I've got x plus 3. The derivative of x plus 3, is 1. And the derivative of 2u to the -1 is? -2 over u squared. So we get -2 over x plus 3 quantity squared. How am I going to solve that? Cross multiply. -2 times 7 is -14 is equal to -2 times x plus 3 quantity squared. Now what? Divide by -2, I get 7 is equal to x plus 3 quantity squared. Now what? Square root. If I square root a squared, I have to list both a plus and a minus, correct? So plus or minus the root of 7 is equal to x plus 3. And finally, so negative 3 plus or minus the root of 7 is equal to x. Notice how we have two solutions in this situation. We need to check to see if they both fall in the interval. So I'm going to take my calculator and I do negative 3 minus the root of 7 is negative 5.6 in the interval. No. So I do negative 3 plus the root of 7 and I get negative 0.35. Is that in the interval? Yes. So in fact, we must exclude the one that does not work, and the answer is x equals negative 3 plus the root of 7. That is the value at which we have that tangent line. What's different about the next one? Sine. Do you remember how to take derivatives of trig functions? Do you remember how to evaluate trig functions? We plug in 3 pi. So we have f of 3 pi. And I get 3 sine of 3 pi over 2. What is the sine of 3 pi over 2? 270 degrees would be?
Oh, 3 pi.
Negative 1. So the sine of 3 pi over 2, the terminal point down there will be 0, negative 1. Sine is the y value, so I have a negative 1 times 3 is negative 3. That is the value of f of 3 pi. Then I plug in 0, f of 0. When I do that, I get 3 times the sine of 0. What is the sine of 0? It is 0. So notice as we subtract these, we have negative 3 minus 0 over 3 pi minus 0. And what do you get? Negative 1 over pi. So that's the right side, negative 1 over pi. And what do we do to compute the left side? The derivative. Okay? Let's use what rule to find this derivative? The chain rule. What is the derivative of the inside? 1/2 times the outside would be 3/2. What is the derivative of sine? Cosine of, then we have x over 2. So 3/2 cosine of x over 2 is equal to negative 1 over pi. Now my guess for the most part that when people encounter this situation, they might struggle to solve this type of equation. We're not used to solving trig equations a lot, so this is a little bit of a review for us. And we're going to try to simplify a little bit from how we kind of used to do it. But what do we first do to solve this trig equation? Divide by 3/2 or multiply by 2/3. So I have the cosine of x over 2 is equal to negative 2 over 3 pi. What's the next thing that has to move? Do I move the cosine or do I move the 2?
Cosine.
How do I move cosine? Cosine inverse. We should first figure out which quadrant we are working in though. Is cosine positive or negative?
What's that acronym?
All students take calculus. Is cosine positive or negative? Is cosine positive or is it negative?
Oh, over there.
Negative.
It is negative, right? The cosine value is negative. In which quadrants is cosine negative? Second and third. Okay, that's where I make my reference angles. So we're going to have to cosine inverse 2 over 3 pi. Make sure you do it correctly on the calculator. I need to make sure I'm working in radians. You are always in radians in calculus. I cosine inverse, and we had 2 divided by, and I have to use parentheses on this, 3 pi. So I'm doing both of them, okay? So I got the 3 and the pi in the denominator. And I get a value of 1.35.
Can you go back to your calculator?
Sure thing. I did not include the negative because we used up the negative when we decided it's in the second quadrant and the third quadrant. Okay?
Okay.
You good? All right, so as I look back at this, 1.35 is not my answer. It's 1.35 radians back of that mark, and it's 1.35 radians past that mark. What is this mark in degrees? In degrees. 180. What is it in radians? Pi. What is pi as a decimal? 3.14. So we are going to go back 1.35 from 3.14. So we have 3.14 minus 1.35. I get 1.79. And I get 3.14 plus 1.35, and that would be 4.49. So as I found those two values, notice on the other side, I have x over 2. So what do I still have to do to these values? Multiply them by 2. As I multiply by 2, I get x is equal to, the first one will be 3.58. And then the next one will be 8.98. I should check to see if those both work. Is 3.58 in that interval?
Yes.
Yes. Is 8.98?
Yes.
Yes.
Yes, because 3 pi is greater than 9, isn't it? So 8.98 will work as well. Okay, it's a little trig review there as well. All right, our last problem of the day, okay? I want you to go ahead and see if you could set it up to this point. See if you could set it up so that you have a derivative on one side, and if you have the f of b minus f of a over b minus a on the other side. See what you can come up with, okay? Yeah. Another 30 seconds here, and I'm going to start putting it up on the board. I see a lot of good work happening. Okay, I have 1/2 for the right side. Did everybody come up with 1/2? And then on the left side, I have my derivative. I had 2/3, so 2/3 x minus 1 to the 2/3 power. I use the chain rule. We all good there? Any questions on how I came up with those values? Okay, so how do you want to solve this? We do cross multiply. It's not going to be that bad of a problem. We have 3 times x minus 1 to the 2/3 is equal to 4. Then x minus 1 to the 2/3 power is equal to 4/3. How do you get rid of a power of 2/3? Raise it to the 3/2. Does that make sense to people that you would raise it to the 3/2? You cube it to get rid of the denominator. You square root to get rid of the numerator, so 3/2. So x minus 1 is equal to 4/3 to the 3/2 power. So x is equal to 1 plus 4/3 to the 3/2 power. Let's calculate that on our calculator. 1 plus 4/3, and we're going to raise that to the parentheses 3/2 power. And I have 2.54. And every time I get a value, I always want to go back and check, is that value within my interval? And is it? It is, absolutely. So we're good. Okay. We don't need to do, oh, there's not another problem listed. Great. But let me check your assignment here. Make sure that I've adjusted some of these things over the years. Good. So yesterday we did basically problems for the front of the mean value theorem worksheet. And then, and so today you're working on the back. I pared it down to just 6 problems. And you don't have to graph them. You don't have to write the equations. All you need to do is find the value C. I want to be clear as you look at the answer key when I post this. I came up with many values sometimes for problems 8 and 9 that involve the trig ones. I will only ask you to come up with 2 answers for the trig ones. So sometimes there's more than one, but if you notice in our work, we ended up with our answers. We tried to make sure we grab those 2 answers that came up within that 1 revolution of the circle. That's what I would be looking for. If there happens to be more, I won't be asking you to find them, okay? It really doesn't come up at all in the AP exam. I've not found a single example, so, okay. Hi. Yeah. You have the rest of the time to work. I'll come around and give you some help. Let me stop my video.